Okay, number 11, they give you 6 to the x and they ask you to make a table. Now, when you pick a table, it's best to pick a table that has powers of 6. So 6 to the 2, 6 to the 1, 6 to the 0, 6 to the negative 1, 6 to the negative 2. So remember, whatever x is, you're plugging it into the exponent. So you're really asking this 6 to the negative 2, 6 to the negative 1, and so on. And these are the values you get for each one. And then when you graph it, it looks like this. It crosses at 0, 1, and you have 1, 6. That's about all you can really graph, because 2 is way up to 36. Makes it difficult to graph something that big. Now 2/3, again, this is just 2/3 to the 2. This is 2/3 to the 1. This is 2/3 to the 0. 2/3 to the negative 1. And finally 2/3 to the negative 2. Okay, and when you ask your calculator what each one of those are, you get these values here, and you can graph it. And it's going down, as you would expect, because it's less than 1. 20 and 20, F and G. F is 3/4, G is 1.5. So 1.5 you would expect to grow from left to right. 3/4 you would expect it to decay from left to right. And that's what each one of those look like. 21, they give you a graph and they ask you to find the original function. So you know that when x is 2, y is 9. So y is 9, x is 2. What number squared equals 9? Well, it's 3 or negative 3. But we can't let a be negative, so we have to choose the 3. Same thing here, negative 1 and 1/5. So y equals 1/5, x equals negative 1. So a to the negative 1 is 1 over a to the positive 1. And so if 1 over 5 equals 1 over a has to equal 5. 24, negative 3, 8. So the y value is 8, the x value is negative 3. A to the negative 3 is 1 over a to the third. And if you multiply both sides by a to the third, you get a to the third, 8 equals 8. And then if you divide by 8, you get a to the third equals 1 over 8. And 1/2 cubed is 1 over 8. So a has to equal 1/2. So there's your function. Okay, now they ask you to match the graph with the function. So if you take 5 to the x and you add 1 to the inside, you're moving it to the left 1 unit. And if you take 5 to the x and add 1 to the known function, you're moving it up 1 unit. So this one has actually moved up 1 unit. That's what this one is, and that one has to be the other one. Alright, now this one, 3 to the x plus 1, they ask you to graph this. So you start with 3 to the x, crosses at 0, 1, at 1, 3, 2, 9. Okay, and then when you add 1, all these points move up 1, every single one. Okay, and so they ask you to figure out your domain. Well, it goes left and right forever, so it's everything. Your range was greater than 0 to infinity, but now it's greater than 1 to infinity. And you had an asymptote at y equals 0 initially, but when you shifted it up 1, you moved the asymptote up 1. So y equals 1 is your asymptote. Alright, now this one, 5 to the negative x. If you start out with 5 to the x, looks like this, and you put a negative in the exponent, it flips it on the y-axis. So that's what this guy looks like. Its y-intercept is at 1, 0, 1. Its domain, it goes left and right forever. Your range, it gets greater than 0 to infinity, so 0, infinity. And you got your asymptote at y equals 0. Okay, now this one, 10 to the x plus 1, subtract 5. So start with 10 to the x, and then figure out what 10 to the x plus 1 is, and then do the same thing, but subtract 5. So 10 to the x comes here. It crosses at 0, 1, and at 1, 10. Okay, and then when you add 1 to the inside of a known function, it moves it left 1 unit. So all these points moved left 1 unit. Alright, and then subtract 5, drops it 5 units. Okay, so it's going left and right forever. Domain is everything. Your range, it goes from greater than -5 to infinity. And you got an asymptote at y equals -5. It crosses at 0, 0, -5. If you plug in a 0 here, you get 10 to the 1, which is 10. 10 minus 5 is 5. So your y-intercept is at 5. Y equals 5. This one's a tricky one. This one is definitely a hard one. When you graph it, you see this weird bump here, and they ask you to figure out what is its range, where is it increasing and decreasing. Well, it's increasing from minus infinity up to 0.5, and it's decreasing from 0.5 to infinity. And its range is from greater than 0 up to a high point of 1.78. I didn't write down what the original function is, but that's what that looks like. 57 gives you a financial question. It says you're investing $8,000 at 6.25% compounded semi-annually, and you change the time to different times here. So this one is 5 years, 10 years, 15 years. So you plug in 8,000, 0.0625, 2, 2, and 5. And you crunch all that down, you get 10,800 something. And then you do the same thing for 10 years, and you would expect more money, and you do. And then same thing for 15 years, and you get even more money. Number 61 says you want to end up with 10,000 after 3 years at 9% compounded semi-annually. How much money do you have to invest? So you're trying to solve for P. So you know everything else. So this part you can crunch down to one number and then just divide both sides by this number, and you get 7678.96. This one, they wanted you to figure out what the average percentage yield, APY, and they tell you R is 0.08 compounded monthly. They want to figure out what the interest rate is compounded annually. So you let T be 1, and if you divide both sides by P, the P's go away. And this guy reduces down to here, and when you subtract 1, you get R equals 0.083, which means R is 8.3%.